following is a demonstration of how a magnetic ballast clarification unit, or MBC, can be used to remove solids from water and wastewater. We are performing jar tests which simulate the operation of the MBC. The first simulation is on stormwater, which contains silt and clay. As a first step, we measure the turbidity of this sample, and it is 369 FAU. We'll now take this sample, put it into the gang stirrer, and begin the simulation process. The first thing we do is begin mixing of the samples, as is done in the MBC unit. We then add magnetite. Magnetite is an inert iron oxide. It's non-reactive, non-toxic, and is found naturally occurring as the black sand seen in many streams throughout the world. We next add a small bit of polymer, and this allows the particles we want to remove to adhere to the magnetite. The magnetite is 5 times the density of water, so once we stop the mixing, particles will settle very rapidly. We only mix for about 30 seconds in this simulation, while in an MBC the mixing is actually about 5 minutes. This allows for a much better removal sometimes of the very, very fine particles that may still be present. The sample, when the mixing stops, settles quite rapidly, with most particles removed in less than 30 seconds. We now take this settled sample, and we're going to measure the turbidity again to show the percent removal of all the particles. The vast majority of particles have already settled out, but magnetite is also magnetic, and so we can remove them magnetically if need to. The final turbidity of this sample was 9 FAU, which represents over 97% removal of the particles. Another use for the MBC is in the removal of biological solids from water. Biological solids such as algae often need to be removed from ponds and lagoons. And in addition, in the biofuels industry, in which they are extracting oils from algae, the algae need to be harvested. And an MBC is very effective at harvesting algae. Our sample here has an initial turbidity of 100 FAU. We again, to simulate the MBC, begin mixing our samples, add our magnetite, which is our inert, non-toxic anchor, which is 5 times the density of water, and then we add a small amount of polymer so that the particles we're trying to remove, the algae, can stick to the magnetite. We mix for about 30 seconds in this simulation, while in the full-scale MBC, the water is allowed to mix for approximately 5 minutes. Again, the particles settle out very rapidly. Most have settled out within approximately 30 seconds. Any of those that have not settled out are magnetic and can be removed in the magnetic separator on the MBC. Activated sludge is also a biological solid, and it reacts similar to the algae when treated with the magnetite and the polymers in an MBC. And as such, an MBC can also be used at municipal wastewater treatment plants that have activated sludge systems. We can get the same removal as what we're doing with the algae here. The turbidity of our treated sample is 4 FAU. This represents over 96% removal of the algae.